Good afternoon, algebra students. We're talking about section 1.6, which is experimental and theoretical probability. We want to talk about this. We've talked about it before in the past, but pretty much we're just going to cover some basics. I've already done some highlighted notes that we're going to go through. But the chance that probability is going to happen is basically the thought is how likely, what's the chance that something's going to happen? And we represent that by using the words P of a certain event happening. And a probability, as you can see below, is either written as a percentage or as a number from 0 to 1. Now, most often that number is going to be a fraction. The chance that something occurs, say, the chance that I pick my thumb out of my 5 fingers. So the chance of that happening would be 1/5. So many times it'll be a fraction, or remember we can write that as a percent, which would be obviously 20%. So the chance that something might not happen at all is called an impossible event, and that would be 0 or 0%. And the chance that something would happen most certainly would be 100% or 1. 1 because what's the chance that you pick a finger out of my hand? Well, that would be 5 out of 5, or 1. So first we're going to talk about experimental probability. Experimental probability hinges on the idea of something happened based on an experiment when we have a number of trials. So I have this example below relating to a soccer team. I'm going to highlight the important ideas here. We're going to score on 16 different times, and we're going to attempt 20 different times. So the probability is going to be written as the probability of scoring. And so that's where you see I have it as a fraction. The time the event happened, 16, divided by the time that it happened in terms of the number of trials, which is 20. So 20 is the number of trials, and the time it occurs is 16. So we reduce that to 4/5, and we convert it to a percentage at 80%. Okay, so that's an example of a real-life situation. I created a table now with random numbers, and each of these random numbers has 5 decimal places. I've just arranged them in columns, and then I wanted to talk about 2 different probabilities, and so I have them down here below. What's the chance that we get a red 7? So I'm going to underline all my red 7s. 1, 2, 3, 4, 5, 6, 7. Now, how many total numbers do we have? 125. So my probability is 7 out of 125, or 5.6%. Then I said, hey, what's my chance of getting an even second decimal? So I went through and I counted up all my second decimals, and I'm going to circle them if they're even. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I've circled all those that are even second decimals. There was 12 of them. And how many second decimals do I have? Well, I have 25 second decimals. So the probability is 12 out of 25, or 48%. I then tried to look at some other ones, and I looked at, hey, what's the chance of getting an odd third decimal? So I went through and I counted up all the odd third decimals. And when I did that, I found 15 of them. And so I reduced that to a fraction as 3/5. So I'm going to put a little note here that when we're talking about a fraction, I'm going to pick a general note and say always reduce. Okay, and that's just a general thing. I converted the 3/5 into a decimal and got 60%. And then for the sake of it, I chose just at random, hey, what's the chance of getting a blue 7? So I looked at all my blue numbers. And in all my blue numbers here, sure enough, do I have a blue 7? I don't. So the chance of getting a blue 7 is 0 out of 125, or 0%. So what are we going to do when we reduce that? The chance is going to be either 0 or 0%. Okay, so we've got a couple different possibilities. We've seen probabilities of 1, probabilities of 0, and things like that. Let's move down now and talk about theoretical probability. Theoretical probability is the chance of something happening based on statistics, based on what it might happen. And so my first example, it uses a number cube, a 6-sided number cube, obviously numbers 1 through 6. And what's the chance of getting a prime number? So first we have to review prime numbers. Remember, a prime number is anything that can be determined that's divisible by 1 in itself. But by definition, 1 is not prime. So I've listed my primes here: 2, 3, 5, 7, 11, and so on and so forth going up. I want to give you a chance just to think. Can you think for a second about what next 2 prime numbers might be? Well, hopefully you thought 13, not 14 or 15 or 16, but then 17 is the next one. And the prime numbers would then continue. Well, how many of those are less than 6? Well, 3 of them are less than 6, so the chance of that happening is 3 out of 6, or 1/2 as I've written above. Now, of the general numbers 1, 2, 3, 4, 5, and 6, how many of those numbers are less than 3? Obviously 2 of them. And so the chance of choosing a number or rolling a die and getting something less than 3 is 2 out of 6, which reduces to 1/3 or 33.3 repeating %. What's the chance of you getting a number greater than 6? Well, there are no numbers greater than 6, so the chance of that is 0 out of 6, or 0%, or just as a number, I guess we could write it as 0. So this is theoretical probability. Notice we have no statistics to pull off of, no tables, no charts, no scoring attempts, and things like that. I then kind of tried a situation with a target logo. We're all familiar with the target logo, and so I've taken the liberty of kind of defining the target logo as having 2 centimeters for the smallest one in blue, and then in black I have the white band having a total diameter, or the total radius of 4, and then the largest band having a total radius of 6. And so my first question is, what's the chance that we hit the bullseye? Well, the bullseye would be found by the area of the smallest circle in red, okay, and I'm going to highlight that in green here, divided by the area of the whole thing. So the area of my whole thing, the radius is 6, and we know that the area of a the area of a circle is pi r squared. So pi times 6 squared is 36 pi. The area of the bullseye, in blue, I have pi times 2 squared, which is 4 pi. So these 2 facts lead me to the idea of my probability. I took 4 pi and I divided by 36 pi. The pi's canceled, and the 4 and the 36 reduced to 1/9. That gives us a probability of 1/9, or 11.1%. Then I said, hey, what's the chance of hitting the red in general? How much red is there? Well, we know that the total is 36 pi. So then I said, the area from the white on in, therefore, is 4 squared times pi, which is 16. So the bullseye, remember, is 4 pi. So 16 minus 4 pi is 12 pi. So that's the area of just the white. So if we take the area of the white, that leads us to the fact of 36 minus 12 pi gives us 24 pi is the area of all of our red. So I took a fraction and I said, hey, what's 24 pi divided by 36 pi? Well, the pi's cancel. 24 and 36 both divide by 12. That gives us a probability of 2/3, or 66%. If you wanted to be exact, you could say 66.7%, or 66.6 repeating percent, something along those lines. All right. I chose homework for this weekend that we're going to work on 1 through 39, but please be aware of the fact that on number 15, you're going to have to look back at page 41 for a table that's shown there as we work through this. I hope this has been clear. Let's kind of go back through and review. First of all, probability, the chance that an event is going to happen divided by the chance of it, the total number of possibilities. Second, probability can go from 0 to 100% or 0 to 1. Probability is written as P with parentheses around the words that you're going to be using. Experimental probability, we're always going to reduce our fraction, the time it occurs divided by the number of trials. Statistically, we can sometimes have random generated numbers to work with, and we're going to have to look at those random generated numbers and kind of determine the statistics from them, always reducing our fractions as we reminded here. And then for theoretical probability, it's not going to be on a table, but it's going to be the chance that something happens, the chance that a card flips, the chance that a dice rolls, the chance that you pull marbles out of a bag. etc., etc., something like that. And here we have an example of a 0%. We could have a 100% as well. And then just reminding and remembering our area formula, pi r squared. We can remember other formulas from geometry as well that we would be expected to remember and be able to use as we're talking about probability. So I hope that's clear, and I hope we'll have a good result as we look through this chapter.